discuss Newton's third law of motion and how it relates to rockets.
Hi, I'm Dan Tani, and I'm an astronaut living here on the International Space Station, flying around the world in every 90 minutes, going 17,000 miles an hour, about 250 miles above the surface of the Earth. And we're here today to talk about the Newton's three laws of motion. Newton's third law of motion says that for every action, there's an equal but opposite reaction. So let's do a little demonstration and see what happens, okay? Okay, so what happened there? I pushed away the water. I lifted my feet, so I was floating, and it went away with the speed, and I went away with the speed because when I pushed, that action had an equal and opposite reaction on me. So the force that we pushed the water off, I used the same force to push myself back. Okay, but I went slower because I have more mass than the water.
And here's one way that you demonstrate the third law of motion every day, whether in your home or in the classroom, by sitting in a chair. Dan is going to explain this to us.
For all of you that are sitting in your chairs, you are putting a force, your weight, on the chair. Okay, but we already said that things in motion stay in motion, and you have a force, that's your weight, going down on the Earth. So how come you're not moving? Well, because there's an equal force that the chair is imposing on you, so that you are just sitting in your chair, and then there's a force that the floor is imparting on you and the chair. So where the chair meets the floor, there's the weight of you and the chair, and then there's an equal force that the Earth places upon the chair so that you don't move, okay? Because the forces have to equal out.
A collision, that's a force. But do you know why only the guy in front moved? The students are arranged in what we call a Newton's cradle. Skater collides with the first student, action. The first student tries to move away from the skater, reaction, but can't, because there is another student in the way. So the force of the impact is passed through the next student and on to the end of the line. Then there's nothing stopping the last student, so off he goes.
Here, students are using the force of air to launch a rover. The air rushes out the back, and the rover moves forward. The force of air can also be used for this rocket launcher. Air is pushed out of the bottle when the student stomps on it. The air travels up the tube. When the air reaches the nose cone, it pushes back down the launch tube and propels the rocket forward, like you see here.
3, 2, 1.
Rockets use a chemical force as well.
This is how rockets work. What rockets do is they throw out their propellant. Propellant is really heavy, and like when the shuttle is on the launch pad, the shuttle and its rockets weigh about 4.5 million pounds, but the shuttle itself only weighs about 250,000 pounds. Okay, so that's what is that? Many times, 4, 16, 20, about 20 times more propellant than there is shuttle. So all that mass gets used to propel the shuttle into orbit. And what it does is the rocket engines create combustion, and it spits out the mass of that propellant out the back of those engines, and that mass pushes, and that force pushes the shuttle into space. And that's how rockets work.
All systems.
So let's review. The third law of motion states, for every action there is an equal and opposite reaction. Rockets use the force of thrust to lift off by expelling gas from its engine. The rocket pushes against the gas, and the gas pushes against the rocket, causing it to move in the opposite direction of the engine thrust coming from the back of the rocket. Thank you for joining us today to learn about the third law of motion and how it relates to rockets.